So we're going to go through again another live lesson, pretty much like I did last time, because generally most of you said that was fine, but you wanted me to slow down a little bit, so I'm more than happy to do that. Obviously, from my point of view, I'm sat in a nice quiet room with not a lot of interaction with you guys, so I need you to tell me if you need me to slow down even more than I am already. Okay, so feel free to either unmute yourself or write in the chat box when you want me to go a little bit slower. All right, so I won't be offended, but please do so. If you've got any questions throughout, all right, feel free to ask them as well. That's absolutely fine. Right, so for our second live lesson, we're going to be having a look at the sine and cosine rules. So as I mentioned last week, the key areas that you highlighted were the circle theorems that we looked at and surds, and then it came to the sine and cosine rule. I have got a little bit at the end, which is fractional and negative indices, but that's going to be time dependent on whether we get to those or not. So I'm going to focus just on sine and cosine as our priority at the moment. Okay, so with sine and cosine rules, what you need to be aware of is that these are generally always on the calculator paper. It's very, very rare that you would get a sine or cosine rule question on the non-calculator. Doesn't mean it never happens, but it is highly unlikely on that one, or it's usually a 1-mark multiple choice question where you would need to apply the rule and then actually just figure out which one of the answers that they've offered is correct at that point. Okay. But the biggest challenge, I think, when it comes to using the sine and cosine rules is obviously there's an awful lot of questions on triangles when you come to an exam. You've got to consider Pythagoras, you've got trigonometry with right angle triangles, so your SOHCAHTOA, and then you've got sine and cosine rules. And the hardest part is to work out which one of those methods you need to be using. You also have area of a triangle as well that comes in. Okay, so obviously you've got your base times height divided by 2, which is very basic, or you've got your half AB sine C area of a triangle as well. So all of those things could be linked to a triangle question. And your challenge is to actually identify what it is you need to use so that you can pick up the marks at that point. If we have a look then at how you do that. So at this point, you've seen this before. It came up when you were doing sine and cosine rules. So it's just a quick way of identifying which rule it is that you need to use. Okay. So if it's a right angle triangle, you have a choice of Pythagoras' theorem or SOHCAHTOA. Pythagoras' theorem is just about the 3 sides, and it doesn't involve any of the angles whatsoever apart from a 90-degree right angle. And when it comes to SOHCAHTOA, it will be 2 sides and 1 angle. Remember, you're either finding a side or an angle, but it will involve 3 things at that point. As soon as it's not a right angle triangle, then it has to be the sine or the cosine rule. Okay, and your identifying features, the sine rule is going to have 2 sides and 2 angles. Remember, you're going to need to find one of them. So it could be, you know, 1 side, you know 2 angles, and you're trying to find the second side, but that's how you identify it's the sine rule. The cosine rule then is 3 sides and 1 angle. Remember, you'll be finding one of them. That does link to the actual formulas that you've got here. So you should have all of these on your knowledge organisers. The main cosine rule formula is a squared equals b squared plus c squared minus 2bc cos a. Okay, you can just learn the 1 rule and then learn to rearrange it, or you can learn the second rule down the bottom, which is to find the angle. The same with the sine rule, you've got a over sine a equals b over sine b equals c over sine c, or you can flip it all upside down. The first one is typically used to find a length, the bottom one to find a side, to find an angle. So at that point, you can then flip it back upside down. Okay, right, if we have a look at some questions then, and I'll give you a go, give you a chance to have a go at the question. So I'll put that first one up. I'll give you a couple of minutes to get started. Try and think about which one it's going to be, what things you might want to label on the diagram, and then I'll see if you're ready for me to start going through it in a second. Okay, right, that's 2 minutes. Is everyone ready for me to start going through it, or do you want a little bit longer? Okay, Matthew's ready for me to go through. Not a lot from anybody else? Okay, right, we'll start giving it a go, but if I'm going too fast, then please do say so. All right, right, first thing we want to do is figure out what it is we're trying to work out. So work out the length BC, so we want to label that side. At this point, we want to have a look at what we've got then. So we've got two angles, we know one side, and we want to work out a side, so therefore two sides and two angles, which means the sine rule. Okay, I would just learn that one particular sine rule and remember that if you need to at any point to figure out what you want, you can flip the whole thing upside down. We then want to try and fill in all of the information that we've got. So we've got A, B, and C already labelled on the triangle. Remember, little a, little b, and little c are diagonally opposite so that we can fill in the formula to give us this. So we've got x over sine 33 is equal to 15 over sine 112, which is equal to c over sine c. So you'll notice that one side is completely useless, which should happen most of the time. Okay, at that point we can completely disregard then c over sine c. We want one of these sections on the sine rule to be useless so that we can figure out what we're doing. At that point then we're trying to get the x by itself. So we would need to multiply both sides by the sine 33 because that's what's happening to it at the moment. It's being divided by that. So we're going to multiply both sides by sine 33. Remember, when you multiply by something like that, it goes on the top part of the fraction. Okay, so that's going to give me x equals 15 times sine 33 over sine 112. You do need to be careful on your calculator. If you do sine 33 times 15 and you don't put the brackets in, you will get the wrong answer. So it's better to always put the 15 at the front and keep the sign of the number at the second part so you don't make any errors with that one. Then you can just stick it in your calculator and you should get 8.8111, etc. And then you can round it appropriately then to what is sensible to you. It doesn't specify in the question, so it is your choice. You could have 8.81, you could have 9, okay, or 8.8. Usually one decimal place is good. All right, so we end up with that one. Anyone got any questions on that first one? Okay, all happy for me to move on? Right, okay, second question then. So I'll give you a couple of minutes to have a look at this one and then see where you are. So see if you can figure out what it is you need to use, try and label as much as you can and see how far you can get. Okay, right, so that's a couple of minutes in. Is that enough time? Or shout if you want a bit longer. All right, Matthew's on it, so we're going to rely on him. Okay, right, so again, we're trying to calculate the size of angle ABC, so we want to identify which angle that is. Remember, the letters tell you, so it's the line that connects A to B to C, and hence then it's the angle sandwiched between them. And we also want to then try and label the other parts of the triangle, so opposite capital B is little b, opposite capital A, little a, and so on. Right, hopefully at that point you can see then we have two sides, we have an angle, and we're trying to find a second angle, so two sides and two angles. And that implies that we're on using the sine rule at this point. Okay, so A over sine A equals B over sine B equals C over sine C. And then we want to try and fill in all of the information. And hopefully, again, you can spot that there is a useless part, so we can completely get rid of C over sine C. And then what you'll notice is this time, the thing that we're trying to find, which is sine B, or B, okay, is on the bottom. Okay, so we don't want to sit there and do an awful lot of rearranging to try and get this bit on the top. So what we want to do is just flip the entire equation upside down. Okay, so we get sine 60 over 18 equals sine B over 20. So remember, you can always do that to try and work out an angle, or you can go straight in with the flipped formula in the first place, totally optional, which you prefer. At this point then, we're trying to get the sine B on its own, so we need to multiply both sides by 20. And remember, the 20 will go on the top part of the fraction. So we end up with 20 times sine 60 over 18. Remember to put the 20 at the front rather than after the sine 60, so we don't get any errors. And then you can work out that value. Now, your calculator will come up with an exact value. It could come up with a nasty decimal, but at this point, you must remember not to round. You haven't finished, because you need to do the last part, which is to get rid of the sine, okay, which means you need to use that inverse sign button on your calculator, so shift sign, where you get sine to the -1 of that value. If you've used the decimal, you've got to type the whole decimal in, or if you've kept it on your calculator, you can use the answer button at that point, and you should get an answer then, so 74.2068, etc., and round it appropriately to something like 74.2. Okay. Anyone got any questions or anything they're not sure on that question? Okay, right, I'll flip up question 3 then. Right, so again, try and figure out what it is you need to work out, label as much as you can, see if you can figure out the formula and get as far as you can with that one. I'll give you a couple of minutes again. Please shout if I am going too fast at any point. Okay, right, that's a couple of minutes. Are you ready for me to start going through the next question? Okay, right, so we're trying to calculate the length BC. So we've got that one there. We can then label our little a, little b, and little c in the appropriate places, and then we've got to figure out what information we've got. So there's one angle in this question, and we've got 3 sides. So we know 2 of them, we're trying to find the third side. So one angle, 3 sides. This time is going to tell me it is the cosine rule. Okay, so the cosine rule is that one. So it is one that you're going to have to learn, same as the sine rule, off by heart for your exam. They do not give it to you anymore. And then we just need to try and fill in as much of the information as we can. So we end up with x squared equals 20 squared plus 23 squared minus, and remember the next bit, the 2bc cos a, all goes together. So it's all enclosed in a set of brackets showing that they are going together at that point. So 2 times 20 times 23 times cos of 55. Now you've got 2 choices. You can work it out step by step. Okay, technically, because it's quite a straightforward calculation, as long as you input it in your calculator correctly, you can put all of that in using the brackets appropriately to get the correct answer. So when you simplify it, you should end up with 401.309, etc. What you need to be careful of is lots of people stop there because they don't have a bit of a sense check about their answer. So we've got a side here of 23, a side of 20. Can we have a side of 401? Nope, there's no way we would be able to draw a triangle like that one, and that's because people forget to do the square root part at the end. Okay, so the last bit that you need to do is square root your answer, and you end up with 20.03 when rounded. Okay, so 20.0 would have been fine. It's totally optional how you round it at that point. Anyone got any questions at this point? Okay, right, we'll have a look at question 4 then. Again, I'll give you a couple of minutes to have a look at this one and get as far as you can for me. So, Callum, I've tried to reduce lessons over the fortnight by 1. So you have 2 live lessons, and then I will do 6 taught online lessons. Is that okay to try and take the pressure off a little bit for you? Okay, right. Are we ready to go through this one? Okay, right, so we're trying to find the size of x. Okay, so hopefully you can see we can label that triangle, okay, and then we can identify the fact that we have two angles and two sides. So if we label it like that, you can have labeled it any way you like, it's totally up to you. But two angles and two sides means that I'm going to be using the sine rule again. I then want to fill in as much information as I can. Right, so use the chat box. What's the issue at this point in time? Yeah, so everything's useful. So what do you think I need to do? Anyone spot what I can do to try and make something a bit more useful? No one spotted it. There should be something you can work out quite nice and quickly and easily on that triangle. Last chance, anyone got it? Good, we can work out angle B. Okay, so there's no useless part at this point. So we need to work out that missing angle at B. That will then give us two useful bits, and then we would be able to ignore the other part. Okay, so angle B, we know angles in a triangle add up to 180. So we can take away the 40 and 46 to give us the angle at B as 94. We can then substitute that into the formula and ignore the C over sine 40 because that's not going to help us at all. Okay, it's a good spot there though, you guys that spotted that one. Right, so at this point, we're trying to get the x by itself. So we can multiply both sides by sine 46. Remember, because we're multiplying, it's going to go on the top part of the fraction. And then we can just pop that in your calculator using your fraction button to get an answer of 14.4 when rounded. Okay. Anyone got any questions on that one? It's just that extra fiddly bit in there that you had to figure out that you needed to work out that missing angle. Okay, so just be careful with those types of questions because it's going to allow you to get so far and then you need to realise, okay, that you need to do a little bit more. Right, yeah, so Matthew's asked me to slow down a little bit, so I'll give you another minute just to write down anything you want from this one. Okay, we ready to move on? Or do you want a little bit longer? Matthew's ready now. Hopefully everybody's ready. Again, please shout if I am going too fast. I'm more than happy to slow down. Right, next question then. Calculate the smallest angle in the triangle. So see how far you can get with this one and figure out what it is you need to use. Can anyone figure out which side or which angle is the smallest one? Whereabouts that one is? Good try, Amelia, but it's not that one. Why did you think that one, though? Okay, so Amelia, why did you think your one? And Callum, why do you think your one? I just guessed. Fair enough. Callum, what about you? What do you mean process of elimination, Matthew? What did you eliminate? Oh, how do I know one of them's a right angle? So, okay, but that still gave me a choice of two, Matthew. If I said it wasn't the one between the 9 and the 17, there are still two other angles, although Callum thinks one of them is a right angle. And Callum says it looks close enough, but if it was a right angle, how would I know it's a right angle? It's not the others would be the same, but if one was a right angle, it's going to have that little square, isn't it, that shows us that it's a right angle. Okay. Unfortunately, Joe's not angling a semicircle because there's no circle on this one. Okay, so that only works when it's actually in a circle for circle theorems. But what you can do, okay, is figure out it's not drawn to scale. If you have a look at that triangle, the 9 centimeters looks at least as long as roughly the 17 centimeters. So we know it's not drawn to scale. But this is the longest side down the bottom. The longest side is going to be opposite the biggest angle. The smallest side will be opposite the smallest angle. So you could have done what Amelia said and guessed and tried this one. But I would say if you're going to try that and you're not sure, you're going to work out this one, you would need to work out this one and then this one to get which one was the smallest. Okay, so you want to be able to do it the fastest way, which is the smallest side is always going to be opposite the smallest angle. Okay, so that gives us that bit. We then want to obviously label everything and identify that we have 3 sides and 1 angle, which is therefore the cosine rule again. Okay, so we know the cosine rule is a squared equals b squared plus c squared minus 2bc cos a. Obviously, we need to label our triangle and then fill in the information. So if we label everything up there, again, you can change it, but what you do want is the fact that we're trying to find this angle over here, and this is the most important angle then in our equation or our formula, which means it needs to be capital A because that's what the formula contains. So that one must be capital A, and therefore 9 lowercase a, but B and C, it doesn't matter. Okay, so fill it all in and we've got that one. And then we can start trying to rearrange it. Now I'm going to show you 2 methods on this one and it's your choice then what you prefer. So this is the standard formula for cosine rule. So we can fill it all in and we can work out all of the values. So 9 squared is 81, 17 squared 289, 13 squared 169, and then 2 times 17 times 13 is 442 lots of cos A. We then want to try and rearrange it. Now our aim is to get cos A on its own. Okay, at the moment we have negative 442 cos A, and I don't want to deal with that negative, so I'm going to add the 442 cos A. Sorry, first of all, I've simplified the 289 and the 169 there for you. But now I'm going to add the 442 cos A to both sides. That's going to give me 442 cos A plus 81, which is equal to 458. All right. I'm then trying to get the cos A on its own still. So the thing least related to that is the plus 81. So I'm going to get rid of that one by subtracting 81 from both sides. And that will end up giving me 442 cos A equals 377. And again, I'm still trying to get the cos A on its own. So at the moment, I've got 442 times cos A. So I'm going to divide by the 442. And that will give me cos A is equal to 377 over 442. And remember, you're trying to actually find the angle A, so you need to use your inverse cos to work out the angle. So it's your shift cos on your calculator, which will give us that. So that's what you want to input. and then you will get an answer then of 31.5, 31.47, depending on how you've rounded it. Okay, so that's one method. It is a completely valid method. It will give you the 3 marks. You would get a mark just for substituting the values in. So that first line of green up here would give you a mark. Okay, typically your second mark would come from when you're at that cos A equals 377 over 442. So that's the second mark, and obviously the third mark then for your final answer. But there is an alternative method. Okay, it's a slightly riskier method, but if you're good at learning formulae, then it's definitely one that you could consider. Has everybody finished with that slide? You're happy for me to move on? Oh, no, okay. All right, boys, just shout when you are ready. All right, if anyone has got any questions at this point, please say. Joe, you done? Not quite. Is there anyone, while we're waiting just for a second, what's the alternative method then? Anyone figured out what else I could do? Anyone spotted? Okay, right, I'll show. Guess again? No. Right, the alternative method then that you could have done is to use the cosine angle rule formula. So if you remember right at the start, I showed you that you have the option of learning the angle formula for the cosine rule, which is that one. As I say, it's just a rearrangement of the original cosine rule formula. So if you're confident that you can rearrange it in an exam, you can just learn the one. If you're not, and you want to try and go for the easier option of just learning this so you can input the values to find an angle, then you can. The caveat that comes with this one, though, is whereas I said that first line of working out on the last question gets you a mark, if you make a mistake on this one, they don't award the marks, because ideally they want you to be able to rearrange a formula. Okay, but so as long as you're not going to make silly errors, then it's fine. But if there's a gamble that you'll make an error, it's better to do it the other way and rearrange it. At that point, then we can just substitute in all the values. If you calculate 17 squared plus 13 squared minus 9 squared, and then 2 times 17 times 13, you come back to what we had last time, which was our 377 over 442, which is equivalent to cos A. So you would get the mark at that point. Okay, so if you can get to there, you have picked up the 2 marks. But if you made a mistake here, you have lost the marks. It's just to be mindful of that one. And then you can do the same thing, so inverse cos it, to get the same answer. Okay, but it is a lot quicker, so that's why you've got to obviously take that gamble. It's your choice what you're more confident with, but you can do that. Okay, anyone got any questions, or are we ready to move on? Okay, right, next question then is this one. So I'll give you a couple of minutes to have a look and get as far as you can, and then we'll go through it. Okay, I can see a few more of you have just joined as well, so if anyone's not said hello in the chat box, can you do so just so you are registered for me? Thank you. Okay, just give you another minute. If anyone's got any ideas, feel free to pop them in the chat box as well as to how you might start this question. Okay, so any ideas then? How am I going to start this question? What is it I need to figure out first? Any ideas? All right, looks like we're all quite quiet this morning. I think that tutor session's worn you all out getting up too early in the morning. First thing then, the question says find the area of a triangle. Can I use half base times height? Nope, I don't know the base, and if I'm trying to work out, well, I know the base, but I don't know the height. If I want to work out the height, I'm going to have to do a lot of work. Okay, so really don't want to do that. So the formula I want to use then is my half AB sine C. Okay, at that point, which means I need to try and work out an angle. Now I've labelled it with the A, B and C in that order, but it doesn't matter. You could have labelled A, B and C anywhere, but wherever you put your C would be where you want to try and work out your angle. Now the formula I've written in red, so area of half AB sine C, so that formula is linking to the red A, B's and C's on the diagram. The reason I've got some green ones is because I don't actually know any of the angles. So I've got to try and figure out an angle. And hence the most useful one to figure out is the angle at C. That means I've got 3 sides and 1 angle. So I'm going to have to use my cosine rule. I can go straight for, if you're confident with, using the cosine rule angle formula. And therefore for the green letters, that's going to link to when the calculation I'm going to do written in green for the cosine rule. So I've rewritten them. Remember, reason being on this one, it's cos of A that I'm trying to find, which is still this angle. So I've just relabeled them. In an exam, they can have it pre-labeled. They can label it with X, Y, Z just to throw you off. Okay, you ignore that and you do what you need to do. Okay, so if you label it to work out either cos A first, you can then cross them out and relabel it again to do the area after. So at this point, we want to input all of our values. So we end up with cos A equals 10 squared plus 9 squared minus 8 squared all over 2 times 10 times 9. We can then simplify that down. So we end up with cos A equals 13 over 20. Again, that should be the point you get to if you've written it out using A squared equals B squared plus C squared minus 2BC cos A. So either is absolutely fine. At this point, then we want to inverse cos so that we can work out what A is. And we get an answer then of 49.45, etc. Now you need to be careful at this point because we haven't answered the question. It's a 5-mark question at this point, so we're only on 3 marks so far. Okay, and you have to use the whole answer, so you should not round until we've finished. At this point then, we can hopefully go back and actually answer the question. But as I say, the most common error is people think, oh, I found the angle, I can stop. Okay, so in an exam, you always read the question first, you answer it, and when you've finished answering it, read the question again to make sure that you have actually answered it. Okay, so we haven't worked out the area yet, and hence we're going to do that next. So we want to substitute in our values. Remember, I'm using the red letters this time. So it's going to be a half times 9 times 10 times sine of that whole answer that I just worked out. So you either have to type it all in, or if you've got it saved on your calculator, you can use your answer button. You can stick that in your calculator straight away, and you get around 34.2 centimeters squared for your answer. It gives you the units on that one, but just remember, if it doesn't, the units would also be worth an additional mark. All right, so obviously we are building up in difficulty here in terms of the questions that you've seen. So this one's just slightly trickier in the fact that you had to do the cosine rule first and then your half AB sine C, hence it's worth those 5 marks. It's worth a bit more. All right. It would also be a case of if you've tried to use either the sine or the cosine rule and made a mistake within this, if you've got an answer of 92.4 as your angle when you use the cosine rule, but you correctly substituted that into the area formula, you would get these marks for this bit in the red. Okay, so if you made an error early on, you can then use that correctly and still pick up the working out marks at the end. So just be mindful of that. If you're in an exam, you really have no idea, but you know how to do this bit, then say an angle is 49 and use that angle to pick up the other working out marks. So don't be afraid to do that. Right, is everyone happy with that question? Ready to move on? Do we need a bit longer? All good. Okay. Right, question 7 then. So this is the last one that I've got on sine and cosine rule. It is also the most tricky. So I'll give you a couple of minutes to have a look at this one and see how far you can get. Okay, I would appreciate it if you have any ideas at this point that you start trying to pop them in the chat box. So if you've got any ideas or any clue on what you would try and do to get started with this question, please fill it in now. Anyone got any suggestions before I start going through it? Okay, you ready for me to go through? Thanks, Matthew. Right, okay, the diagram shows a logo. We know AB and E and DCE are congruent triangles. So congruent is keyword there, which means they are exactly the same size. Okay, they can be rotated or flipped around, but where we've got A to B is 26, we know D to C is 26, D to E is going to be 15, and the angle at the top here is also going to be 38. Okay, so these two triangles are exactly the same. BCE is a sector of a circle, okay, at this point. And what we're asked to do is show that the area of the logo is 510 centimetres squared to 2 significant figures. So we've got an awful lot of working out to do, hence I said this was the worst question. This is kind of at the top end of grade 8 into grade 9 and would be right near the back of an exam paper. So our starting point is we want to work out the areas of the different shapes. We've got 2 triangles there, both the same, hence I've labelled them both number 1, but we can start using our area triangle formula of half AB sine C to figure out what the area of those two are. So if we input our values, it's going to be a half times 26 times 15 times sine of 38 and work it out. And that's just the first triangle. So that could be triangle ABE. And then to work out the value of the other one, we've got 2 triangles, so we will double it and we can work out that the area of the 2 triangles together is around 240.1, etc. Now remember, we haven't finished answering the question, so we need the full value. Highly unlikely on this one that you're going to be able to use the answer button, so I would write it all down so that you have that to help you. Okay, The next thing then is we want to work out the area of a sector. So we did this quite a while back when you were in school. Area of a sector is just a fraction of the circle. Okay, so it's the angle or theta out of 360 times the area formula, which is pi r squared. So it's just what fraction of the circle have I got times the area formula. When I start to fill this in, I will get 108 over 360 times pi times, I don't know what the radius is. Okay, so that's what I need to do. So the radius is the bit that I need to work out next. Right, has everybody finished with that bit of information? Okay, so I'm going to carry on then on the next slide. At this point then, the radius is the line that connects B to E or E to C. Either of them are a radius. And hence we have one angle, 1, 2, and finding a third side. So that tells me I'm going to use my cosine rule. And then I want to fill in all of the values again. So remember my angle up here is at A. So this one's going to be my cos A. So this R will be my lowercase a, and B and C don't matter, but you can label it however you want to. And then we need to fill in the information. Okay, so we get R squared is equal to 15 squared plus 26 squared minus 2 times 15 times 26 times cos of 38. We can simplify all of that. That's going to give us R squared equals 901 minus 780 cos of 38. Remember, you can stick it in your calculator in one go as long as you're accurate. And then you work that out to give us 286.35, etc. Okay, and remember that last step so that you don't forget it. You need to square root to find the radius, which gives us 16.92, etc. Again, don't round until the end. All right, so hopefully you're okay on that one. We ready for the next bit? Okay. Right, so we can go back to using our radius formula to work out the area of part 2. So the area of 2 then was, go on Matthew, you've raised your hand. You got a question? Or is that to slow down? No, happy to go? Right, so back to the formula then. We've got theta, which was 108 over 360 times pi times my radius squared. So I have got dot, dot, dot there, so I do need to either use the answer button or type all of that in to accurately work out the area of the second part there, the sector, which gives me 269.88, etc. Okay. At this point then, I need to go back to the question. So show that the area of the logo is 510 centimeters squared. So the area of the logo is the two triangles added to the sector, which means 120 for the first triangle, 120 for the second triangle, and 269, etc. for the sector. Add them together, remember not rounding at this point because that could be the difference at the end, gives me 509.980. I'm rounding it to two significant figures, so I've underlined the two significant figures, which are the 5 and the 0, and the 9 is the number that tells me whether I round it or leave it alone. So because it's a 9, it's 5 or more rounds it up, so that's going to round it to 510 centimeters squared to two significant figures. Okay, so I'll give you a couple of minutes just to write that down. That's the last question that I've got on sine and cosine rule. So I'm just going to give you a bit of information in a minute about next week. And then if you want to hang on and go through, I've just got 3 questions on fractional and negative indices because a few of you requested that, okay, when you gave the feedback last week. So I'll just put a few of those questions on the end for you to have a look at. Everybody finished with making any notes on this one? Yes, please shout if you need me to stop or slow down. Okay, right, so next week, obviously Thursday the 2nd of July, again at 10 a.m. It is 3 lessons next week. So as I said earlier when Callum asked the question, what I've done by speaking with SLT is managed to reduce the 7 lessons for you guys, because most of you are engaged and doing a lot of the work and doing very well with it, is that you will have 3 lessons each week and then 1 live lesson each week. Now, next week you've got vectors. Okay, so that's kind of a new topic, building on what you've done with the vectors in transformations this week. However, ideally, I'm going to spend, because it's quite a complicated topic, next week's live lesson, I want to work on vectors with you. So I'll go through some examples with you, and then obviously you've got some time after that to go and do some practice on it. So out of the 3 lessons next week, I need you to do the first 2 lessons, so lessons 1 and 2, prior to the live lesson, so that you understand what I'm talking about in the live lesson, but leave the 3rd lesson until after I've been through the examples and done some exam questions with you. Okay, anyone got any questions on that at all? All right, so they'll appear. And obviously the week after that, you've got your end of cycle test. So that will be the cycle 3 exam. So it's going to be a 90-minute exam paper for you to have a go at. And then I will give you the answers so that you can mark it. And then my aim in that live lesson is to be able to answer any questions that you have on those questions. All right, so that will give you the opportunity to go through in more depth or ask questions about the ones you weren't sure on. So just remember, the revision topic list is on the Google Classroom at the top of the page, so that you can see what topics are on the exam for you. Okay, right, so as I said, we've got about 5 minutes or so left. So I'm going to have a look at fractional and negative indices. I won't be offended at this point if you think, no, I'm brilliant at them, I don't need to watch any further, and you want to disappear. So it's totally up to you. Okay. Right, just a reminder though, if anyone hasn't said hello in the box, can you please just do that in the chat box before you disappear for me? Right, so fractional and negative indices on this one. These are always going to be on the non-calculator paper, because they require you to make sure that you can use your brain rather than calculator to work out the answer to these. The things that you need to remember are, when you have a fractional power, the denominator is always the root and the numerator is the power. So if you have got your knowledge organizer in front of you, then you can have a look at those to see how you do, or how you use the fractional powers. The other one is the negative power. So as soon as it's got a negative power, you then find the reciprocal of the number, which means you flip it upside down. Okay. So the first question that we've got is 64 to the power of 2/3. So I'll just give you a minute to have a quick look at this one, and then I'll go through it with you. Okay, ready for me to start? Shout if you want longer. Right then, so as I said at the start, with a fractional power, the top number, so the numerator tells me the power, the denominator tells me the root. We always want to do the root first, because it's easier than dealing with 64 squared. Okay, so we don't want to do that. So top part power, bottom part root. That means I'm doing the cube root of 64 and then raising it to the power of 2. So the cube root of 64 is what number times by itself, times by itself, times by itself again. Okay, will give us 64, which is 4. And then I need to square that, giving me 16. Okay, so you've got your 2 marks there. Your first mark would come from the top line, so the cube root of 64, then squared. And then obviously the second mark for getting 16 correct on that one. Okay, second question then, so remember there's only 3 of these, so it's not going to be too painful, hopefully, is this one. So work out the value of 125 to the power of minus 2/3. So that negative is important to think about to start off with. All right, so I'll give you a minute to have a go at this one, and then I will go through it with you. Okay. Are we ready? Right. Okay, so as I said, we've got a negative power to deal with first, which means the reciprocal. Technically, 125 is a whole number, so it's 125 over 1. So reciprocal means we flip it upside down, and we get 1 over 125, still to the power of positive 2/3 now. So because we found the reciprocal, the power has become positive at this point. And then we're doing like we did with the last question and applying the power and the root process to 1 over 125. So the 2 is the power, the 3 is the root, which means I want the cube root of 1 over 125, then square it. Now this is like surd laws, okay, so it's bringing in part of your surd laws, which means where we've got the cube root of 1 over 125, it's the same as a cube root of 1 over the cube root of 125, so it makes it easier for us to work it out. The cube root of 1 is just 1, the cube root of 125 is 5, and then we need to square that, so we end up with 1/5, and then again the power law applies to both the top and the bottom, so it's 1 squared over 5 squared, giving me 1 over 125. So marks wise on this one, you would get a mark for the first bit up here, so the cube root of 1 over 125 to the power of 2. They can sometimes give you the mark for the first bit, the pink bit up here, depend on where they are, so it will be either of those two, but you've definitely got it by this point. Your second mark would be when you get down to the 5th, and obviously your third mark for the final answer on that one. Okay, is everyone ready for the last question? Right, here we go. So I'll give you a minute just to have a look at this one. So remember, you've got a negative there again. See if you can figure out what you're doing on this one. Okay, we ready to have a look? So first of all, we want to always deal with a negative bit first. Okay, so the negative tells me I need to find the reciprocal, which means flip it upside down. Okay, so because it's already a fraction, that makes life easier. So it's now 4/3 to the power of positive 3, because we've already dealt with the negative. And then just like we did in the last one, the power of 3 applies to both numbers. So we've got 4 cubed over 3 cubed, which we can then work out. 4 times 4 times 4 gives me 64. 3 times 3 times 3 gives me 27. It doesn't specify to write it as a mixed number, so you are absolutely completely fine to leave it as 64 over 27. All right, that would get you 4 marks. They would probably add an extra mark on if they asked you to convert it into a mixed number at a later date. Okay, but that's it from me for today. So if you've got any feedback, please let me know. If you've got any questions before you leave, then by all means stick around and ask at this point, or if there's anything else you want to know, please ask now.